great university, Dr. Professor G. Reddy, and Professor Sengen Sanepin, Nagita University, Thailand, Professor Ha Feng Anton from Thailand again, and Kremlin Mark Ampo, Republic of Philippines, and Dr. Srinivasan, and all of the dignitaries. There are many dignitaries I know, Dr. Singh and Jay Kumar and all those people. Forgive me if I don't remember all those names, if I missed to call you. Thank you for this opportunity. And so at the outset, I'd like to congratulate the Professor Pasekaran Srinivasan and his team to organize this particular conference on a topic. I think it gives me. Initially, I thought about vaccines and what biomaterials. Well, this is all two different big topics, and how come? And again, look at very carefully. This is not vaccines conventionally or biomaterials conventionally. Okay? It is on animal health. Is quite indifferent. Okay, the animal health part is taken away by veterinary people. Okay, the immunology part, I think the vaccination is taken by immunologists or so-called virologists or microbiologists, and the clinical side is taken over by health people like doctors and all of the group of associates, and like that. It's a mixture of topics. It's very complicated. It's not a straightforward. And again, it is put as the recent trends. Oh my God! How do I give you a comprehensive account of a recent trend on this? I can tell you, and if you have any of those, I think I have given a little write-up. You can read what of all the issues of this one particularly. So I thought important. Why is vaccine is so important? How it is, I think it is important for us. Okay? So if you think about it, vaccine, I think it's all started in the 1700s. That's the way I think the history records. If you give me the Jenner, the year 1749, Jenner, okay? And so he was responsible for creating a vaccine. The unfortunate organism to live on Earth is the smallpox virus. As probably one of the few viruses that we have eliminated. Okay, very successfully we have eliminated because it doesn't know how to overcome the vaccine development. Okay, so afterwards, I think if you look at it and from point of view of economics. Okay, so it is about just a second. The market value is about 180,000 billion, 180 billion US dollars. Okay, 180 billion dollars. The vaccine technology is worth. That includes all human anything. Okay, so it is projected around 400 to 500 billion US dollars. The vaccine technology alone. Okay, whereas this particular part, if you look at it, the biomaterial side is about 250 billion dollars. Okay, and so it's more than that. Okay, so this is a potential. Two different areas, and it can be combined together and sometime. So biomaterials are conjugated with the vaccine technology and delivered, and very successfully, new materials are coming, and they are evolved and developed against all kinds of pathogens. So look at what are you going to work? If you are going to work with animals, who is going to give you money? This is what I was joining for PhD, and my professor was teaching on monogenians. It's a kind of parasites that occur in marine fish and freshwater fish. So I asked him what is the use. Anyone can answer what is the use of doing research on a particular parasite? Okay, the answer is the scientific interest. Okay, so it's not economic interest. The scientific, it has got merit. Okay, it has got scientific interest if it is not immediately economically beneficial. But you don't know. When plastics was discovered, hardly envisaged and this is going to be used like this, or when electricity was discovered, it was envisaged this is going to be applied universally throughout the world? No. When it was discovered, you don't know the use of it and how people are going to use it. So it will come to some extent, somewhere, some people will use it. So it's scientifically important. Okay, fine. I gave me PhD, fine, I got on and I looked at all kinds of biology, bionomics and whatnot, even reproductive science. And also looked at electron microscopy and the surface features and also internal feature, architecture of the cellular. And again, when I was teaching molecular biology, I don't know where I am. All those kind of southern blotting, western blotting, northwestern blotting, and even eastern blotting. I don't know what kind of blots are all. It's all very some modern technology. That's the time I think as a zoologist I have to move to molecular biology. So when I went there, and I don't know, I've never cultured a bacteria, and they live alone cloning, isolating a particular gene, and so I started working on plasmodium falciparum and drug-resistant gene, and okay, fine. The gene was not there in the library. Genome library was not there. And what the hell you do? You spend 1 year. It was a waste of time. Then I think I was going to UK where somebody was waiting for me to continue to work on 12 different clones. 12 different clones of facial hepatica. How many people know facial hepatica, facial gigantica? This is animal liver disease. Okay? So 4 flukes, if you got infected, human facial hepatica is there. Forget about it. It's only animal. Okay? Only 4 flukes are needed to kill you within 3 months' time. You don't need more than that. Only 4 flukes can be infected. You can experiment yourself. Okay? So, that's the kind of fluke I was working at. This was a gene, I think, isolated from tegument of facial hepatica. And the person was worked for 3-4 years, left it in the middle, and the supervisor was, you don't know what stage it is, where it is, and he picked up all those clones and gave it to me. I looked at it and examined it. It was it's a plasmid. The clones, cDNA was cloned in a plasmid, 2 different clones. So I started working. So you would have heard about sequencing, DNA sequencing. I think those days manual sequencing was as the regular thing. Whereas automated sequencing is very, very rare. I'm telling about 93. Okay, so I tried to sequence it, and the first 12 reactions, nothing was there. Okay, so then I thought where I was doing some mistakes, I forgot. So instead of putting single primer, I put both of them. So it was reading this way, no sequence came, and again I did it correctly. All 2 different codes were sequenced very beautifully. It was done, the work was done in 1993, it was published in 2000 in Press Study. Okay? What was done in 1993, what was published in. So this clone was expressed. Okay, the clone was expressed, the protein was isolated, the protein was purified, and it was challenged against the facial hepatica in animals, and it gave 60% protection against facial hepatica. It's a very big organism about this size. Okay, it gives 60% protection. So all this clone is only a single gene, it's a tegumental gene, and that gave us about 60% protection. Think about it now. All other proteins, other tegumental proteins who are given better would have acted as better vaccine, but single gene gave us this result. Okay, so all different experiments were shown to prove, and this was giving 60% protection challenged against in rat. Okay, so that's the work I think I can tell you very relevant to your the topic on vaccine. Okay, so think about all other kinds of virus. I was only pure zoologist. Okay, and I'm nothing to do with microbes. Okay, why I went to microbes? The money was in microbe, but too in the aquatic diseases. That's a very, very important kind of, where all the bacteria and viruses, I think even today remains to be identified and worked out. All diseases, what you think about in a human being and animals is also there in aquatic organisms. So it's all there. You have to, and luckily or unluckily, I think there was the outbreak of white spot disease was 93, 94. I think that's what people were crying for help. Government of India was crying for help. Nobody was there. Nobody knows what is it, why it is, and why all the, I think, there was $10 billion worth of shrimp farming industry at that time. Collapsed immediately. They wanted a pretext. There's no pretext can be given. And I think a lot of projects were given, including me. I think I was very successful at that point of time. One of them was from UGC, 35 lakhs. Another one, it was about 75 lakhs. It's a giant project with the Fisheries College, Bangalore Fisheries College, and also Veterinary University. They were very successful in that respect. And where do you work with your virus in your aquatic system? Tell me it's a shrimp. It's a beautiful, beautiful industry. You start with the one shrimp and produce about 8 million larvae. One adult will give you 8 million. I mean, correct, Jake, 8 million to 10 million larvae. And that gives you about 3 rupees at that time. One larvae is equal to 3 rupees. Think about 8 million to 3. That's the money people are making. Okay? Those people like me in that point of time in aquatic science or zoology, they were all doing this, were minting money. Okay? And this kind of brooders were collected from the natural sea, and one brooder will cost about 25,000 rupees at that time. And they give you about 10 or 20 or 30 mother prawns, give you to multiply to 8 million. So that's the kind of money that was printed. And think about it, nobody wanted to give a sample in those times. Okay, even for sampling diseases or experimenting with it, we luckily got it. And all those projects, including Monoderm baculovirus project, we got one, and the white spot virus project also we got it. We worked on something. I think we came out with some kind of solution for it, but there's no solution. I think people are feeding with meat. Okay, the shrimp were fed with the meat. Okay, think about it. They're not legally allowed to feed them, but they did, and diseases will come. So this is not the only shrimp, but also fish, and also in cattle. And cattle about, what about this viral disease that we got, COVID-19? Where does it come from? Anybody? I think the secret students will be there. COVID-19, some kind of, okay. COVID virus, I think Bob Hanna came, one of my supervisors from UK. Okay, he used to come and he delivered a talk in 2004, and at that time, avian influenza. Okay? He was telling avian influenza. Ramasamy, don't you have H1N1? H1N1? Yes? Have you heard about avian influenza H1N1? Okay, H1N1 is a very common type. There are other types also. Okay, people have come out with some kind of vaccine. As a kind of spray kind of vaccine they have come out with. You spray with your nose and it's treated. I think they say, but he was cautioning. Okay, he was cautioning. Ramasamy, don't you have H1N1 in India? You have so many chicken farms here. If you say there is no H1N1, I don't believe it. Okay, that means what? So if exfoliant comes in, no cure, no possibility of cure at all, because it will change its antigenicity and it will go on multiplying again. Same thing is happening with COVID. I was in a hospital working for almost 8 years now, and I told all the doctors, COVID-19 is not going to rest for only this time. Okay, it's going to come again and again. Mutant form will come again. I warned them, but now they believe. At the time, they refused to believe. Okay, so every organism has got its evasive property. Okay, mimicking property. Have you heard about Schistosoma mancini? Schistosoma mancini, salad. There are a couple of Schistosoma species affecting human beings. It's not only animal, but also it affects. It occurs in the one of the vein, hepatic vein. So nowhere else. It will be sitting across the lumen of the hepatic vein of all the animals, including human beings. Okay, the adults they start releasing eggs. All the eggs is very very small. They will go and where it will be all deposited in the kidney. Okay, the glomerulus kidney, they will all be deposited, and I think you will have bloody urine. If you have hematopia, Schistosoma hematoria, Schistosoma mancini, all those kind of infections, unfortunately not in India. Not in humans are not infected in India, but animals are infected. But doesn't mean you will not be infected. If you go to a scenario area and you'll get infected. But it occurs in, I think, Indonesia, Thailand area, and again the South Africa. Okay, there's the two regions where schistosoma are infecting, animal infecting and also human infecting. Those schistosoma, vaccination was developed and it was applied, but what was happening with trypanosomiasis was also happening in this organism. It was sloughing off its surface. Whenever antibody go and bind the surface of the parasite, it sloughs up that protein, it synthesizes a new type of antigen. So by the time it's recognized, it is antibodies are produced and it's going binding against slough. So it will be every time it's changing, and a new type of vaccines are produced. So that's the way. So if it's going to be there, that kind of evasive mechanism are going to be there, then what are the techniques you would come across? How do you produce a vaccination is going to be a protection? That's the whole hypothesis that we are trying to produce all this vaccine technology. And so what about reverse vaccinology? Reverse vaccinology. So that's how that we work. You have the mRNA and you prepare a cDNA and you express the protein. So collect the vaccine, and that's the reverse engineering vaccination or some kind of things. That's the modern kind of, but this kind of techniques was there for a long time. So what are the companies? There are many companies are there, but only few companies after COVID-19 they made billions of rupees. Okay, and in India, I think one of the companies, Santa Biotech, and the other kind of the Hyderabad, Pune-based companies. Okay, they do all vaccines, like anti-rabies vaccine, anti-smell vaccine, and so these are all the kind of pioneering work are done. Okay, Serum Institute. There's another institute called Human Biological Institute, India. And there are a number of companies, but only few companies are making money. So I would say, and whatever you study, attend the conference, the take-home message is that already players are there. So India is already supplying for, I think, more than 60 countries. Okay, and for vaccination they are producing. And where we are, what are the things you will be taking? Okay. So what is what's the past, what's the present, what's the future? So you should have some idea how to start a vaccination technology, okay? Vaccine technology or even the biomaterials, okay? So you should take out and produce it. I can tell you biomaterials, okay? Simple example, I was working and we got some good publications also in 2022-23. I can tell you very simple. You know human placenta? How many of you would know? Human placenta? So it's a biomaterial. Collagen is a biomaterial. Okay? All kinds of, in the fibrils that we find in the tissues are all biomaterials. Okay? So the placenta, not only human placenta I'm talking about it, so you can take any placenta. So the advantage is all the growth factors are there in the placental membrane. So you take the placental membrane, you apply any wound and you will be immediately healed. Don't need it. You apply, you process it, right, fine. If unprocessed is there, people also try, where is it applied? So then what else? What is there better than a placental membrane for curing any kind of even incurable disease like diabetes? Okay? So we have developed the technology and also we have taken some patent. Okay? The human placenta which was available for in the hospital, so we processed it, we freeze-dried and dried it and made optical surgery, people make it. You know, there will be a membrane applying there to heal all the wound very quickly. Okay? That's the membrane we have developed. It's a biomaterial, for example, so telling you. Okay. No, we will go on telling this, probably I'm taking others' time. And so it's a very important area. So you should take one bit of it. So it may be biomaterials or even vaccine. And you should start your own industries. Don't hesitate. The more you are qualified, the more unfit to make money. You know that? The more you are qualified, the more you are ready, and the more you are unfit, okay, to do any business, okay. So you start your own business, take small idea and capitalize it and venture it and do it. You can do it. People not qualified, they have all the industries, and because they have money, all the qualified people go and work there. That's the trend I'm telling you. And people have made big money, and it's never too late. And you can think about this is a very beautiful area. I congratulate Dr. Vasilikiran and his department, all his colleagues for organizing this kind of very nice conference. And again, I thank one and all and our Vice Chancellor. Okay, thank you very much for this new opportunity.
Thank you, sir.